class, welcome back to my YouTube channel, and for today we are going to discuss the lesson 21, which is about solving logarithmic equations and inequalities. So how can we solve these two, the equations and the inequalities in logarithm? So first, let's discuss the solving of logarithmic equations. So here are the things to consider in, or the strategies we need to remember in solving logarithmic equations. First, it is the rewriting of your logarithmic equations or logarithmic form to exponential form. So if you can, for you to easily understand, or if you are more familiar with exponential form, you can rewrite the logarithmic form in exponential form. And we can use the logarithmic properties. So we've discussed the basic properties, the different laws, and the change to base formulas. So you can use those logarithmic properties in solving the equations. And we can apply the one-to-one property of logarithmic functions. So the one-to-one property can be discussed in our further later. And last strategy, we can use the zero factor property. So what are this one-to-one property and zero property? So first, let's discuss the one-to-one property of logarithmic functions. So for any logarithmic function of x equals to log v of x, if log v of u is equals to log v of v, then this value u and v is equals. So u and v is equals. So that is the one-to-one property of logarithmic functions. So we can further understand that in our examples later. So how about the zero factor property? So the zero factor property is defined as if our a times b is equals to 0, then a is equals to 0 or b is equals to 0. So if we multiply a times b and then their product is 0, then one of this value, either a or your b, is equals to 0. That is the zero factor property.
So let us have our first example in solving logarithmic equations. So in solving logarithmic equations, we need to make sure that our bases, if in exponential equation, make sure that your bases are both the same from left side and the right side. So in here, we need to make sure again that our base for the logarithm, so remember we have this form, log to the base x. We have c. So now, let's determine rather if we have the same bases. So we have here log. For our first example, we have log base 4 2x equals to log base 4 of 10. So we have log base 4 to our left side and also log base 4 to our right side. So this means they have the same bases, and we can now easily get the power, which are 2x to the left side and 10 to our left side. So the value now we have, let us divide both sides by 2, which is the numerical coefficient of our x, So 2 divided by 2, that is 1. So we have x here. And then 10 divided by 2, that is equals to 5. So our x here in this first logarithmic equation is x equals to 5. Let us have our second example. We have log base 3 power of 2x minus 1, which is equals to the exponent 2. So, based from our, if we are going to recall the properties that we have already discussed, one of the basic properties is b raised to log base b of x is equals to x. So, if we are going to try to apply it in this example, we have to raise both sides with the base. So, we have 3 here and 3 to the other sides. What we do on the right side, we will also do in the left side. So, since we have here 3 log base 3, and it says here that b log with the base b power of x, we have equals to x. So that means the value that will remain here is 2x minus 1. 2x minus 1. And to our right side, we have 3 raised to 2, or 3 squared, which is equals to 9. So we have an equation 2x minus 1 equals to 9. We need to transpose negative 1 to the right side so that we can have the term which has an x to our left side. So we have 2x equals to 9 plus 1. Or simply, you need to add 1 to both sides. So, plus 1 here, it becomes 0. So, we don't have constant term here. Then, 9 plus 1. So, we have 2x equals to 10. Dividing both sides by 2 to get the value of x, we have x equals to 5. So, again, the value of our x in this logarithmic equation is x equals to positive 5. Let's have the third example. We have log base 2 of x plus 1 plus log base 2 of x minus 2 minus 1 equals to 3. So we have here an addition of logarithmic to the right side and the exponent in the right side. So if we are going to recall one of the properties of one of the laws in of logarithm, so we have 3. So the product rule, the quotient rule, and the power rule. So we can apply here the product rule. So let's recall the product rule. Log base b u times b is equals to log base b of u plus log base b of v. So this one is the same, this form is the same to our example here. So we have log base b of this of the value u plus log base b, which is 2, of the value x minus 1, which is v. Now we are going to apply this rule to our example. So we will have log base 2 of x plus 1 then times x minus 1, because log base b of u times b. So that is equals to 3. Now, since we have this we have here the log base b, log base 2 rather, and we have here the exponent. We can apply also the property b raised to log base b of x, which is equals to x. So we can write an base here, which is the same to the base of our logarithm, which is here, in example, we have 2. So we input 2, then raise to this logarithm, then 2 raised to 3. So getting the evaluating this 2 raised to log base 2 x plus 1 times x minus 1 will be equals to the x value. So what will be the x? What is our x value here? So that is the x plus 1 times x minus 1. So we have here x plus 1 x minus 1. That is equals to 2 raised to 3. So this value. Now, let's expand this product. The product of these two monomials. So we have x times x, we have x squared, and x times negative 1, that is negative x, and then positive 1 times x, that is plus x, and positive 1 times negative 1, that is negative 1, and equals to 2 raised to 3. So we have 2 times 2, that is 4, times 2, that is equals to 8. So let's simplify. We have x squared minus x plus x, so we have x minus x, that is equals to 0. So cancel this. We'll have x squared minus 1 remaining equals to 8. So let's transpose negative 1 to the right side, or the same with adding plus 1 to both sides to eliminate this constant term and combine it to the same constant term. So we have x squared equals to 8 plus 1. So we have x squared equals to 9. Getting the value of x, since this is x squared, meaning there are two values of our x, or the solution for this logarithm, there are two values. There are two values. So in getting the value of x, we can get the square root of both sides since we have a squared an exponent of 2 here. So square root of x squared, that will be equals to x. So it just cancels the square root because square root of x is just the same as x raised to 1/2. So x raised to 1/2 times 2, that will be equals to 1/2 times 2, that is equals to 1. So we have a remaining x here. Then the square root of x, the values we have are positive 3 and negative 3. So these are the values of our logarithmic equation given here. Let's have our last example. We have log x squared plus 2 log x minus 3 equals to 0. So in this given logarithmic equations, we have an common logarithm because our base here is 10 and we are not writing the base 10 already. And now we can treat this log x as a variable. So we have log x. This log x, we are getting this squared. So we can let our log x to be equals a certain variable. Let's say an a. So let's substitute log x, which is equals to a. So this one, log x, we have a, then squared plus 2 times a log x minus 3 equals to 0. So this equation, as we can see, is an example of quadratic equation. So to get the value of the variable a, we need to get the roots. So how can we get the roots? Let's factor this quadratic. Okay. So we have a squared plus 2a minus 3. So let's factor negative 3. We have we have 3 times 1. So we have 3 times 1. So what will be the sign of 3 and 1? So we have here positive 2a. So to get positive 2a, the value should be positive 3 minus 1. So we have here plus 3a minus 1. These are equals to 0. So now we have the factors, and the value will be a plus 3 equals to 0, which is a is equals to negative 3, and then a minus 1 is equals to 0. The value of a is positive 1. So we have here a is equals to negative 3 and a is equals to positive 1. So since our log x is equals to a, we can say that our log x is equals to negative 3, and again another value, or log x is equals to positive 1. How can we get the value of our x? So we have here a base 10. When we are going to transform this logarithm in an exponential form, we have a base 10, and the value of our exponent is negative 3. So what will be our x? Our x is equals to 1 over 10 raised to 3, or 1 over 10 times 10, that is 100, times 10, that is equals to 1,000. So this is the first value of our x. Next, we have log x equals to 1. Transforming it in exponential form, we have 10. The exponent is 1 equals to x. The value of x is equals to 10 raised to 1, which is equals to 10. The values of our x in this given logarithmic equation are x is equals to 1 over 1,000 and x is equals to 10. That's it for solving logarithmic equations.